Good. Awesome.
Share screen into Teams.
Oh, it's gonna make me restart Teams for this.
Of course.
Max.
Just that way it's 6 now anyway.
Yeah. It's waiting to let me in. I let myself in? That's awesome. Look at that.
You're being let in again. Fun times.
I had to restart. I had to restart the client. Okay. Now share. Boom. There it is. Thank you so much.
You're just sharing a screen of it's going to just record this side.
Okay, I think we're good.
Ready?
Yeah, thanks so much.
All right, everyone, thank you for your patience. Here today we have Eric and Whitney. They are the co-founders of Recon, and today they'll be speaking on security operations with Velociraptor.
Awesome, thanks a lot. Thanks so much, folks. Really appreciate you all showing up to catch this talk, especially right after lunch, or even actually during lunch, depending on what time you eat. Really appreciate the B-Sides Tampa crew for having us out here. They reached out actually not that long ago. It's kind of a last-minute plan for us to come out here. They reached out because they wanted us to run our DFIR CTF. I said, I'd love to. And so we said, well, if we're already going to be here, let's do our best to submit a talk and see if folks want to hear about this really awesome tool that's near and dear to our hearts. I'll give a quick round of introductions, and then I'm going to explain a little bit about what Velociraptor is. Because even if you've heard of it, which many of you probably have at this point, I'm hoping that this talk is going to shed some light on things that maybe you didn't know it was also very capable of. So let's dive into those intros. So a little bit about me. My name is Eric Capuano. I'm the CTO and one of the co-founders of Recon InfoSec, which is a managed detection and response provider out of Austin, Texas. So simply way to put that is we are a SOC as a service. Everything on the defensive side of security operations we handle, from threat hunting, detection, containment, eradication, all of the above effectively. So we are blue team at heart. We are defenders, and that's kind of where our passion lies. I also teach digital forensics and incident response for SANS, for those of you that are familiar with SANS. And we've both taught for several years now at Black Hat. So if you go out to Vegas in the summertime, you can actually catch us out there teaching live incident response inside of a simulated corporate network, and that's a lot of fun. Like many of my colleagues at Recon, I'm a former Air Force and Air National Guard member supporting cyber warfare operations out of Lackland Air Force Base in San Antonio. A lot of cool experiences there, met a lot of really good people, and convinced half of them to come and work with me at Recon, so that was fun. And I had another previous experience standing up the first security operations center for the Texas Department of Public Safety, which just like in the state of Florida, right? That's everything from state police, highway patrol, all the way down to driver's licensing, regulatory services, you name it. So it's a mission critical network, 450 locations across the state of Texas. And when I arrived, there was no security capability at all. By the time I left, my team was publishing threat intel back up to US CERT. So we had really kind of made a name for ourselves as a small, underfunded state agency. We were doing really good work. And I got to say, one of the secrets that I picked up in that time was figuring out how to be highly effective at security operations with a shoestring budget. And that's where you'll quickly find out that open source is the magic answer. It really is. So, hopefully you're in an organization that has an open mind to open source, because if you don't, you're missing out on some of the most powerful tools out there. And I'm talking even comparing to those really expensive off-the-shelf tools that we trust so much for unknown reasons. So that's one of the things we like to show off about open source, is it can get a lot of good things done. Hopefully I didn't hit a nerve there. All right. But let me turn it over to Whitney, who's actually kind of the superhero of our team. She's the lifter of many of the awesome things that we do. You're gonna have to speak up though.
I'm not good at speaking up. I'm Whitney Champion. As Eric mentioned, I'm one of the co-founders and the lead architect at Recon InfoSec, formerly Red Hat Booz Allen Spaywar. My background is largely in cloud security and large-scale security infrastructure automation and orchestration. If you are familiar with the DEF CON Hacker Tracker, that was my brainchild many, many years ago. And if you see anything with angry eyebrows floating around the community, that chances are it's my art as well. You're welcome.
Awesome. So let me give a high level agenda of what we're hoping to cover in this very, very condensed 45-minute session here. So we're going to talk a little bit about what Velociraptor is. For those of you that haven't heard of it, prepare to be enlightened. It's going to be one of your new most favorite tools. It certainly is one of mine. Then we're going to talk about some of the things that it can do. Like for instance, and remember, this is a SecOps talk. So this, Velociraptor is well known as an incident response tool, and it is a phenomenal one. But what a lot of folks don't know is that you could use this daily, every day in your SOC. Your IT team could even get value out of Velociraptor. So I'm going to talk about things like deploying and managing your other security agents, your EDR, Sysmon, whatever. Velociraptor can kind of be like the supervisor of those things, right? So there's a lot of cool things we can do there. There's things that we can do with these scheduled hunts and server events to basically keep a constant watch on certain things in our environment with nothing but Velociraptor in play. We'll also talk about how we can get real-time visibility into what's happening on our endpoints, right? Which, of course, you probably know, well, that's what my SIEM does. Okay, but not everybody can afford a SIEM, right? And even though there are open source SIEMs, that's a lot of elbow grease to stand that up. So what if I told you Velociraptor is almost as good, if you have nothing better, to start getting real-time telemetry and eventing of what's going on inside your network, and even the ability to respond to those things, right? And then we're going to get into, okay, now what happens when it hits the fan? Bad guy breaks in, starts trying to, encrypt files, whatever. All right, now can we get involved with Velociraptor and do something about it? Absolutely. It's actually probably one of the things it shines at the best, and that'll spill right into instant response, containment, and remediation there at the end. So let's talk about what it is. Now, folks, let me tell you, even though it probably sounds like Velociraptor is going to be this wildly complex, like who knows, this is going to be really impossible to stand up, deploy, and even use, that could not be more opposite of the truth. It is the most simple thing you will probably ever try to deploy, even if you've never done anything like it before. You pull down a single executable from GitHub, and you deploy your server with it. And then that same executable, that's what all your clients are going to use. It just runs with a slightly different configuration, right? So that's it, a single executable, and you now have a Velociraptor server, and you could have tens of thousands of Velociraptor clients all connecting back to that server, giving you a real-time command and control capability of all your endpoints, whether that's just getting visibility, reaching into file systems and pulling back malware, or responding to a threat actor that's actively, wreaking havoc inside of that network. So it doesn't get any easier than this, right? For those of you that have been around long enough to remember a project called GRR, Google Rapid Response. Yep, see a lot of heads shaking because GRR made a dent in the open source IR community because it was a very, very powerful toolkit. Let me tell you, one of the developers of GRR was Mike Cohen, who eventually, branched out, left Google, and created Velociraptor basically as a way of saying GRR could have been a lot simpler than it was. because one of the biggest complaints about GUR was it's very powerful, but who's got time to stand that thing up and keep it running and alive and all that stuff. So basically, he wrote Velociraptor to be the predecessor, or I should say the successor of GUR, and he did a rock solid job at it. Let me just kind of show you. So imagining that you drop your Velociraptor server on a box and you got all your clients out there, the agents are connecting back to the server. You log into that server and you have a very, very simple and intuitive web interface, right? So you're not dropping to a shell and running SQL commands here. We can very easily pop into this list of clients here, and I can see every one of my agents that are checking in. I got a green light saying these are connected in real time. So anything I want to do to any of these systems, it's going to happen instantaneously. And by the way, that agent running on the box, it runs as a system level service. So there's no limit to what I can do. I have God mode on that box, right? So anything under the sun I can do, which, yes, for anybody thinking a little mischievous here, would be detrimental in the wrong hands, right? So keep that in mind. But that's true about any tools that we use, security tooling especially, right? You would never want an adversary to get access to your EDR portal, right? Well, same thing here. So you want to make sure that this is something you do with defensible architecture in mind. But once I log in, I take a peek at all these endpoints checking in. I can drill into any one of these endpoints to get more information, browse the file system. I'm going to show you some of that here in just a bit. I can also very smartly apply specific labels to subsets of my systems. So for instance, maybe I've got a pocket of systems that are critical, right? My domain controllers, Exchange, or if I'm a law enforcement agency, I probably got CGIS systems. If I'm a critical infrastructure, I probably have SCADA, ICS systems. I can get in here and label and tag all those systems so that in the future, I can run very targeted hunts. Hey, I only want to hunt for this artifact on these subset of systems or these or the others, right? So that's a pretty cool capability to have as well. So let's say I decided I wanted to drill into one of these systems and take a deeper dive. Like I'm picking on this desktop device here. It's running Windows 10 Pro. Okay, got it. And we're going to click into it and see what we can do inside of the context of this system. Right, so clicking into it, I now have a summary of that endpoint, right? I've got its unique client ID, some version information, all that kind of good stuff, some operating system, full qualified domain name, all that. Okay, cool. Now, there's a variety of options that I have access to in here. And one thing I'm pointing out, the reason this arrow's up here is because this is what's reminding me, as I start clicking through some of these other menu items up here, this is reminding me the context of what I'm looking at. So I'm looking at this system, this desktop machine here. Now, I'm going to do a deeper dive into some of these other functions and features, but I'm going to go ahead and hand it off to Whitney to talk about how we can use Velociraptor to orchestrate our security agents of any kind, right? Whether it's Sysmon or Carbon Black or whatever, using Velociraptor to maintain full posture of those agents.
All right, so as Eric mentioned, we use Velociraptor heavily for agent deployment and orchestration, something we do a lot in our line of work. So whether it's Sysmon or WinLogBeat or FileBeat, it could even be your EDR agent that may or may not be a headache to deploy. Well, Velociraptor allows us to do that really quickly and really easily at large scale, which is why we use it. And so Velociraptor comes with a lot of artifacts. Well, they're called artifacts in Velociraptor. We'll get to that in a minute, but it comes with a lot of artifacts out of the box, and one of those is Sysmon. So it's specifically built for deploying Sysmon across all of your endpoints. So in this case, we're going to create a hunt, say, hey, I want to take all my Windows boxes and push Sysmon to everything that's out there. So this is the windows.sysinternals.sysmon install. You may or may not be able to read that. That's the name of the built-in artifact from Velociraptor to deploy Sysmon. And it uses something called tools inside of Velociraptor. So it's a tool inside of a tool, basically. So if you see, we've got two tools listed. One is the Sysmon binary and one is the Sysmon config. So what Mike Cohen has built into this is essentially a really simple way to deploy binaries or config files or you name it really smoothly, because what it does is it uploads those files to Velociraptor. So this does two things for us. There we go. This allows us to download the binary or config file or whatever it is, it downloads it to the Velociraptor server. So now your endpoint no longer has to go and reach out to some third party. It's just going to go reach out to Velociraptor and say, hey, give me this file, because Velociraptor has already fetched it and stored it. So you no longer have to have another communication that may or not be blocked on the network in that particular environment. The other thing it does is it caches that file. So if your system has to reuse it or grab it later on in the artifact, it's already there, the executable or the XML or whatever file it is you need. So this is basically just going to pull down the sysmon binary in this case. So we know how to deploy sysmon via a hunt, but one of the things that we don't want to do all the time in all of our environments is go deploy this manually. So one of the really powerful things about Velociraptor is this thing called client event monitoring and client event artifacts. So essentially what we're going to do is say, hey, set it and forget it, because we don't want to do this over and over again. We're going to use basically labels, which are built into Velociraptor. The name of the label is arbitrary, but hey, we want everything that's labeled Recon 99 to check in and get this artifact that is called Windows Check Service. The name doesn't matter. But basically what it's going to do, it's going to set up a job that runs constantly that goes and deploys this to everything labeled Recon 99.
A really good use case of that is if you know you want 100% deployment rate of a certain agent like sysmon, then this means that the second Velociraptor gets installed on this box and it checks in, Velociraptor is going to push sysmon automatically without delay. So it's just a way to kind of know you've got that full coverage that you expect to have.
And what it's going to do is, depending on the time frame that you put on here, it's not just going to run it when it checks in. It's going to run it when it checks in, and then every X amount of time from there on out. So it could be every 5 minutes, it could be every 5 hours, it could be every other day, every month, it doesn't matter. But you can essentially set it and forget it and say, hey, I want this thing to run indefinitely on all of these systems. It could be by OS, it could be by label, whatever you need. And in this case, it's just everything that's Windows is going to pick up this artifact. So this is the artifact that it's actually running behind. It's an artifact, there's an artifact, there's an artifact, it's all fun. If this is also all VQL, which if you're not familiar is Velociraptor query language. So yet another query language to have fun with. Basically what this is doing is this is going to go say, hey, is sysmon on the box? Yes or no? Well, if it is, cool. If it's not, go deploy it. If the service is there but it's not running, go start it. If it's running, we're all good. Continue on, and it doesn't do anything. Because what we don't want is it to keep redeploying. We just want it to make sure it's there, make sure it's happy, and move along. So this is basically just for grins what it looks like on the back end when it does run. It says, hey, I've checked in every 10 minutes from here on out. We're okay. I'm not going to deploy anything. Just basically to give you visibility into what it's actually doing.
Because imagine, I mean, you might deploy sysmon to 10,000 endpoints, but do you know every hour of every day that sysmon is on those endpoints and is still running, right? That's essentially what this is doing every 10 minutes. Oh, and if it stops running, guess what? We're going to start it right back up. So even if you get an adversary, in there jacking around.
Or a customer who wants their stuff turned off, because we've all been there, and it'll turn it right back on and they won't even know. So one of the really powerful things that Velociraptor allows us to do is what we're doing here in server event monitoring. So we can schedule hunts, we can schedule all kinds of things in here, and this allows us to do a lot more with our endpoints and a lot more with our data. Does anybody in here use Velociraptor currently? Oh, good one. One guy. Well, we use it a whole lot in IRs and incidents to do triage acquisitions of particular endpoints. And so that requires going out, gathering a whole ton of data from a whole ton of endpoints, and then doing something with that data. So Velociraptor lets us do that very quickly, very easily at scale, whenever we need to. Where am I?
What triage tool could you use?
Velociraptor. Velociraptor, yep. That's at the end, so stick around. We'll talk about triage. You bet.
So one of the things that's already built into Velociraptor is a artifact called cape file. So if anybody is familiar with cape by somebody, one person at least, is familiar with CAPE. It's a tool by Eric Zimmerman. CAPE is not open source, but this particular list of files is. And what that list of files is it's all the things that we should go collect when we're in the middle of an IR, don't know what we need to get off the box. So this list is built into one of the artifacts in Velociraptor, and we can go pick and choose the MFT, registry, hash, whatever we need to get off the box, endpoint logs. All that stuff will get pulled down and bundled up. So this artifact is essentially going to sit here and monitor and wait for us to run that triage on any endpoint and then say, hey, what do you want to do with this data? And in this particular instance, we're going to say, watch for us to run this CAPE artifact. And when it's done, take all those files, zip them all up, and then shoot them up to S3. But this doesn't necessarily have to be S3. It can be wherever you want your data to go, which is what makes this really powerful, because you can do lots of other things with data that would otherwise have been a royal pain in the butt to go gather. This is a snippet of the artifact. The full, oops, what did I just push? Oh. Where am I?
You're going forward, man.
I'm hitting the back button.
You're still.
Why am I hitting back?
You're hitting forward.
No, but I hit back.
Okay.
There we go. There we go. So this is a snippet of the artifact. Eric and I did a talk a couple years ago. It was Breaches Be Crazy. It was on the Send for Summit. And so it was in this repo that we give you the full dump of all of that. But that was also really useful. So say you've got thousands of endpoints and you want to be able to gather all of this data from all of your endpoints continuously. Velociraptor allows us to do that really easily, because there's already all of these artifacts bundled in it that go grab users, go grab network information, go grab services that are running, packages that are installed, anything that you want to gather off of an endpoint and keep that data in. It could be a CMDB, it could just be a different inventory backend. You get all these things regularly and gather them, and you can basically use those same server monitoring artifacts to pump them into a backend database.
How many times has a Atlassian bug or a managed engine 0-day dropped, and you'd love to answer the question, where's that software in my network? Right? I'm gonna tell you right now, that's a tough question to answer unless you've got a lot of real expensive tooling. Well, Velociraptor is already on the endpoint. You can already interrogate, get those software packages, bring them up to the server, pump them into a database, and now you've got a running snapshot of all software, all users, everything on those endpoints in a database.
So these artifacts are called server event artifacts, and so that's exactly what this is doing. It says every morning at 3 a.m., go grab everything from this artifact and pump it into whatever backend database of my choosing. And in this case, it's just services, but like I said, it could be packages, it could be users, it could be network information, whatever it is you want to gather and ship elsewhere. So this particular artifact will take anything from an artifact name that matches a regex of your choosing. It says, go grab all this data from all of my endpoints and then push it to a SQL server. But like I said, it can go anywhere. You can push it to Elastic, you can push it to Splunk, SQLite S3. It's very flexible, and the other benefit of it being open source, if you want to ship it to a different kind of endpoint or a different kind of backend, it's totally doable and totally buildable. And that's yours.
Okay.
Yep.
Awesome. So let's talk about some of those visibility things that we get to tap into here. And, you know, folks, you know, you're going to start to see some capabilities here that you're going to say, yeah, but my EDR can do that. Okay, I would agree, but I would also ask you to compare the price tag, right? Because EDR is nice. It's nice when you have it. And I've worked with a lot of orgs that don't have the budget for some of those types of tools. So keep an open mind when I show you some of the things that we're able to do here with this awesomely free tool. So here we are back at that endpoint screen, right? So I'm taking a look at one of my systems in my environment, and I want to take a deeper dive. I want to be able to maybe run some commands, you know, maybe just, you know, poke around a little bit here. So what I can do is I can drop into this little icon right here. My arrow's misaligned, sorry about that. But the shell icon here, I click into that, and now I can execute any command on this box, whether it's a PowerShell command, CMD, bash for applicable systems, you name it. and I can run a command and I can get the results right here. Now that might sound trivial, but it's actually not, because right, to be able to get a command prompt on a remote system securely, you really got to kind of know what you're doing there. Well, this is a local system service running on this box, so I'm not like passing credentials or anything like that in order to run these commands. So yeah, I could just, ask quick questions like, hey, show me all your running processes with the get process command, and there you have it. There's all my running processes. And as you know, with something like PowerShell, there's no limit to what I can do here, right? I could run a download cradle with an eradication script and, blow an attacker off a box before they know what happened. But that's kind of cool, but I'll also admit a bit manual, right? I'm not necessarily going to be using this on every IR I do, and that's also not the way that Velociraptor was designed to be used, but it's kind of neat that I can do that. Now, here's a really cool trick and a really undervalued capability. If I wanted to drill into the file system of this endpoint, right? How many times have you wished you could reach into someone's computer and get that one macro-enabled Excel document out of their downloads so you could quickly deconflict, is this a threat or not, right? I don't want to call the user and say, hey, we're looking at your email. Can you forward that to me? So what if I could just reach into the file system and grab a copy of it myself? You bet. So what we do is we click into VFS. And as you can see over here on the left-hand side, I've got a full directory tree of the C drive. In this case, we also have a D drive. I can also go into the registry hives, just like they were a file system. And I can drill down to any location on this disk because I have full privileges on this machine. So there's no protections that are going to stop me. I can go into that user downloads directory and say, that's the file I want right there. Let's click download from client. And what it's going to do is it's going to fetch that file off the endpoint, ship it up to the Velociraptor server, hash it a couple times, which, you know what? That's probably all I needed right there. Right? I'm going to take that hash, plug it into VirusTotal, and find out what this is really quickly. But if that's not enough, if I want this sample in my little hands, I'll just click this right here and download it off the Velociraptor server onto my analysis workstation and start taking it apart, right? So that's pretty cool. But that's just one example, right? Another example I like to show here on this next slide is, and this one's probably nearly impossible to see, but I'll walk you through what's up on the screen right now. Is there are many very juicy forensic artifacts that we know and love when we're doing IR, especially around the usage of PowerShell. And one of the artifacts that we love with PowerShell is what we call transcript logs. These are logs that basically capture an entire PowerShell session in a text file on the disk in the user profile that was responsible for creating it, right? So what I can do is I can browse to that location and I can peek right into your PowerShell session and see every command you ran and every output of that command, just because I have this ability to browse the file system here remotely. So that's kind of neat. Same thing goes with the registry. So all I'm showing you here, and forgive me, I think it just gets harder to see with the dark slide, but what I'm showing you here is we've dove into a specific location of the registry where a well-known tool like sysinternals toolkit, right? Now this is just sysmon, but sysinternals also includes tools like psexec, sdelete, some of the evil tools we don't like to see a whole lot of. Well, I would say right now, this is a really juicy indicator of compromise. When I can find the EULA accepted flag inside the user's registry hive, I know that they used that tool, right? And I could just easily browse to that location there, right there in the VFS, just like it was a file system. Okay, now, but let's say I really want to use Velociraptor for what it was designed for. It was designed for very systematically pulling and parsing artifacts off of an endpoint, right? So let's go through that process here and pretend we're gonna dive into one of these endpoints and we're gonna go collect specific artifacts from it using the built-in artifacts that Velociraptor ships with. So in this example, what I'm gonna do, this is a bit more sophisticated than a minute ago when I ran get process, just to list the processes on one system. You know, it'd be a lot more powerful. What if I could get processes on 1,000 systems at one time? Bring all of that data back and say, just show me the least common or the rarest processes, or the ones that are not digitally signed, or some combination of the two. This is exactly how I'd approach that. So I'm going to run a hunt across all of my endpoints saying, get the running processes. The artifact I'm going to use for that is this one right here. It's called windows.system.pslist. Now, this is a lot juicier than just simply running get process, because it's not just getting processes here. What it's also going to do for me is it's going to enrich those processes with additional information like the hashes of the executables, as well as the authenticode code signing status of those binaries as well. Because just looking at process names, I don't know, SVC host, there's 12 of them. I don't know which one's legit or not. But when I start bringing in code signing status, full path information, as well as the hashes, I can very quickly find anomalies in this environment. And the more data I have, the easier it is to find those anomalies, because I'm going to use things like least prevalence, right? So that's what we're going to work towards here in this example. So we'll build this little hunt here. We're going to run this across a handful of endpoints, and let's take a look at the results that come back. So we're back here at the hunt manager screen. So up on the top half, you can see where I created that hunt. Get all running processes. Well, down below in this little notebook, these are the results of that hunt. And there are probably thousands of rows of results that come back. I'm not going to look through all of those. I'm going to use the power of the notebook and just say, hey, I only care about the least prevalent. So the processes that came back on the fewest number of systems. They're rare. That's interesting. But I'm also really interested in things that are not trusted, meaning they're not digitally signed by a trusted publisher. That's another anomaly. And as it happens right here in this screenshot, there is definitely malware to be found. And you don't have to look very far. Matter of fact, you could just pay attention to the counts here. That's a pretty clear giveaway. And then the next giveaway is the untrusted code. I don't know about you, but I don't like the looks of either of these executables, right? Just going out on a limb, maybe something worth looking into. In this case, it was absolutely 100% malicious, but just showing you, like, I didn't need any fancy tooling or big seam or anything to find this, right? And that's pretty cool. So here's another use case where, hey, remember the example I gave a few minutes ago? A new 0-day drops, right? Because that never happens. New 0-day drops in some kind of Java, desktop runtime environment or whatever, Adobe PDF, whatever. Okay, and you need to now answer the question: where are we exposed? Where in our network are we running that version of that particular software? Again, not an easy question to answer without certain types of tools. Well, same thing I just did. Go and get all the programs on all the boxes, period. When that data comes back, I'm going to use a notebook to basically search and filter for a certain file or certain program name, a certain version. The sky's the limit. I can also use the prevalence tactic. Show me the least commonly installed software in this environment. Why do I only have TeamViewer on one system out of 500? Right? Might be worth looking into. So that's another cool trick, right? This isn't super down in the weeds, incident response-y. No, this is basic everyday security operations. Know what your least prevalent executions are. Know what your least prevalent installed programs are. And there's some pretty quick wins here. So this is just me scheduling that hunt, get software on all systems, kick that off. There's the artifact we're going to use, windows.sys programs. And you know what I love about these artifacts is that it's not closed source. It's very, very transparent about what it's doing. Hey, I'm going to query these registry keys and get all the installed programs from these locations. And this is how I'm going to parse the results, how I'm going to name each column that comes back. If you don't like it, you could click the edit button on that artifact and change it to be whatever you want. You want to add more to it? You want to get it to do something fancier with it? It's all open, ready to be changed to do exactly what you want it to do. So we've run that hunt against, in this case, 54 systems to go get all the software that's installed. And then here's just yet another example of how we can use least prevalence. So notice how I've got them sorted by count here. If you're wondering how I did that, this is a preview into the notebook editor where I can basically choose exactly how this notebook gets parsed. Because there could be thousands and thousands of results here. I don't care to look at all of them. So I'm going to write a little query in this notebook that says, okay, here are the columns I want to see, and I want to group and count based on the display name, display version, and what have you, right? And then I'm going to filter out this noise like language packs or anything signed by Microsoft. Don't care about that. And then we're going to group and we're going to sort, right? So this is the result. I've got mainly only the least prevalent software in this environment now here. And that's what made it possible to find things that you might want to make sure the SOC knows about, right? VNC servers, Hide My Ass Pro VPN, there's, CCleaner, WinRAR. I mean, I'm just saying, I'm not saying all this is evil. I don't know. Anybody know what this is? K-Lite? Yeah, K-Lite, but then you use something like uTorrent, right? I don't know. All I'm going to say is that might violate some sort of, acceptable use policy, right? But okay, all right. But moving on. Real-time eventing now. Okay, because another critical capability of any security, especially IR teams, but security teams just as much, is having visibility on an endpoint in real time. Not just a point in time, get the data and go parse it somewhere. No, I mean what's happening right this second. We can do that here, and we can also configure Velociraptor to forward logs for us if we needed to in a pinch. So let me show you a couple examples of the real-time events that we have access to. And by the way, this view right here that I've got up, this is basically just the artifact browser. When you're gonna run a hunt and you're looking for a certain artifact and you're not even sure what it's called, just start typing up there in the search bar, and it's going to automatically filter for artifacts that have that in the name. It's a quick way to find out what can Velociraptor even do, right? Search for the word execution, search for the word, you know, MS-1710, search for all kinds of fun words, and you're going to see a lot of built-in capabilities here. But okay, so in this case though, I'm looking at one particular artifact called Windows ETW DNS. And so ETW, we're using the Windows Event Tracing to basically watch in real time every DNS query made by this system. That's actually a really hard piece of telemetry to get, I promise you. There are no really built-in reliable ways of watching all the DNS queries that a system makes unless you've got network sensors, right? Or you've got the DNS server logs, but you can't force a client to use your DNS server in many cases. So I just want the endpoint to tell me every DNS query that it makes and ship it in real time up to Velociraptor, so that when I get a little IOC like malware.com and I want to know every system that has resolved that domain name, I'll very quickly be able to figure that out with these DNS events. Another similar example, and this one's hands down my favorite. Process creation. I tell my students all the time, one of the most valuable telemetry sources I have in an environment is process creation. Because I don't care if it's nation state, 0-day evilness or script kiddies, they're all going to involve process creation. They're all launching programs, launching processes, launching, you know, LOL bins or whatever. So process creation is where the truth lies. So that's one of the first telemetry sources I go to turn on when I get into an incident is I need process creation. If nothing else, this. All right. So in a pinch, I can turn on this artifact in Velociraptor, and it will start watching every process creation event and ship it, stream it real time to Velociraptor. So not only do I know that, okay, you know, Excel just launched VB, you know, some Visual Basic script through the WScript engine or something, but I know the parent and ancestry of that process as well. So let me show you an example of what that looks like here in just a quick sec. But as most of you are hopefully familiar with, you've got things like Sysmon already. Right, Sysmon does a really awesome job at this too. DNS queries, process creation, file system timestamp manipulation. The list goes on. So wouldn't I just put Sysmon in the box? Yes, you should. Absolutely. And what if I told you that there's a built-in artifact that you've already seen will deploy Sysmon for you? There's another one that will ingest its logs and ship them to Velociraptor. So if you already know the value of that telemetry, now you've got a free way to centralize it if you don't have something better. Now, what I'm not saying here, folks, I'm not saying that Velociraptor is all you need for telemetry. Okay, I'm saying if it's all you have, you can get a lot of value out of it. So this is an example. If I had flipped on, for instance, process creation tracking on an endpoint with Velociraptor, and then started streaming those events in real time, this is what it would look like. So what I'm able to see here are all the processes that have launched. You can see them all down here, but notice under the call chain, I get to see basically the ancestry of that process, because no process launches itself, something launched it, and something launched that parent too, right? So I can kind of follow the tree, and this is a quick way to start to identify anomalies, because maybe SBC host is legit, but if it was not launched by a legit parent, that might be the thing that kind of keys me in on something out of the ordinary here. So this is just phenomenal. And by the way, real time. So I can just sit here and watch these events just stream in, which is very valuable if I know I've got an adversary on the system and I don't want to miss a beat. I want to see every command they run. I want to see every process they launch. I can sit here and stream that. And then this is just a similar example, but in this case, what I'm actually using is not the built-in eventing. I've got Sysmon on the box now, and I've just simply told it to forward the Sysmon logs. It's the same type of output here. So I've got, in this case, network connections. So on the left-hand side, you see all the processes that are creating network connections. But now I have, for instance, destination host name, destination IP, destination port, and when it happened. So I'm seeing real-time network connection information. Between process creation and network connections, there's nothing you can do on this box I'm not going to see, right? And that's kind of neat for free 99. But let's get a little, I know some of you in the room are like, okay, I was hoping for a little bit meatier topic. So for the limited time we still have here, I'm going to move a little quickly through some of these, but bear with me, folks. Anybody wants to talk about it, we'll hang out, we'll answer questions. But threat hunting detection, yes. What if I want to hunt for threats? I don't want to sit here and watch in real time. I only want to hunt for specific threats. Like, for instance, somebody once told me that Kerber roasting is this very terrifying credential theft attack because any user in my environment can do it. They don't require any kind of privileges in order to Kerber roast attack. So I could go from regular user to domain admin with this technique. Sure sounds like something I should be looking for in my environment, right? There's a built-in artifact for that. So I could turn on this Windows Events Kerber roasting detection, and now Velociraptor is constantly looking for signs of Kerber roasting in my environment. Hey, that's cool. How much does that cost again? Oh, it's free. Right, cool. Awesome. Another tool. Now, this is another tool I'm going to bolt on here for a quick second. You want to find threats on an endpoint in seconds, and you don't have a seam? Let me tell you about a quick tool called Hayabusa. You might already be familiar with a tool that's like it called Chainsaw. It's been around longer. Hayabusa is kind of the next thing. What Hayabusa is a very small, lightweight agent. You could drop it on an endpoint, and it will scan all the event logs for about 1,200 different well-known threats. Well, I can just deploy that with Velociraptor. And now I can do that across 10,000 systems at one time. Well, Eric, you should use a seam for that. Yes, but if there's not a seam, this might be my next closest capability to a seam, and that is phenomenal capability here. So thanks to Whitney and I, we decided to turn that into an artifact. So that's a built-in capability. You can run Windows Event Logs Hayabusa. It'll push it down, run it, and just show you where the threats are in those event logs. And this is just simply what it looks like to run that artifact. No big deal here. If you ever want to get hands-on with it, be sure to check it out. Basically, what it's doing is it's pulling down all those well-known threat signatures off of Sigma. But it also has its own built-in threat signatures as well. And it's just going to go through and parse those event logs looking for bad guys like it has done here. So we ran this against an endpoint that definitely had threats on it. And this is the result from the Hayabusa execution. So it discovered several critical level detections, Cobalt Strike service installations used in lateral movement of the Cobalt Strike beacon payload. So again, pretty cool for two tools. The price is double though. If you use Velociraptor and Hayabusa, it doubles the price, but they're both free, so you're still cool. All right, this is just a little gee whiz into what a Sigma signature is. I'm not going to go into that, but I did drop a link here in the slides, and this talk is recorded. But if you want to know more about the detection rules, the Sigma project is one you must know as a defender. And you probably should know as an offensive person too, because that's how we catch you. But good stuff. We love Sigma. All right, but let's take it even further, right? So another one of those really fancy EDR-only capabilities is, what if I suspect there's a threat actor in my network using some evil tool like Cobalt Strike? You know what would really be an easy way to find them? What if I could just send a Yara scan for Cobalt Strike beacons in memory of all of my systems? Well, that sounds expensive, right? But Velociraptor can do it as well. So all I have to do is say, hey, I'm going to Yara scan processes on every Windows system in this environment. And what am I going to scan for? Well, check this out. If you go to this artifact, Windows Detection Yara Process, which as you can derive, scans processes in memory with whatever Yara signature you want. If you come to this artifact and change nothing, just leave it the defaults. The default Yara signature is Cobalt Strike Beacon. I could change nothing and just say, yeah, sure, go ahead, launch. And you are now finding one of the most prolific attack tools in the world, in memory across all your systems in a matter of minutes. I think that's kind of neat. But hey, you got better Yara signatures than that? No problem. Just provide a URL to that signature or upload it right here, and you're scanning for whatever you could possibly imagine using this agent. And it's not only able to scan the processes, it can also scan the file system, whatever you want it to do, it'll find the stuff. So if you want to get savvy with Yara, there's so many open source repositories of Yara rules. It's really just the limit is your imagination of where to go get fancy, fun Yara rules that you could feed to Velociraptor and immediately start hunting for threats. All right, but let's say we found some threats. I got some bad guys in my environment. I don't like it, but I need to know everywhere that they are. I need to fully determine the scope of this intrusion, right? Maybe all I have is the name of a file, the name of a process. Can I use Velociraptor to find everywhere that the bad guys are? Yes. So what we'll do is we'll say, I want to find IOCs across all my systems. So in this case, the IOC that we're choosing here is the name of a couple really suspicious executables that we've already found, right? We saw this when we were just looking at rare processes in our environment, untrusted processes. So if these are those executables, what I'm able to do here is I can search the file system of every system in my network for the presence of these files. It'll take about 30 seconds or less. I don't care how many thousands of systems you're going to run this on. It's very, very, very fast. I could also use a YAR rule or whatever. And hey, by the way, I could say if you find any of these, go ahead and hash them or even just upload them to my server so I can analyze them further. Run the hunt. What do we get? We got hits. We got hits on this system here. IT13 has hits for those file names at these locations, and there's the scope based on the IOCs that we provided. That's kind of neat. All right, so we're gonna move real quick here because I think I'm out of time. Feel free to give me the boot, folks, if I'm holding up the next speaker. But if I wanted to get into full incident response mode, I can absolutely do that. So I've already identified a few systems. Maybe I want to know everywhere that the compromised user has been. I can use an artifact like this one here. Event logs RDP off. Provide that a regular expression pattern for a compromised user, like in this case, James Denard. Sorry, James, your creds have been stolen. The attacker is using your account to move around our network, and I need to know everywhere James Denard's been. This artifact is going to answer that question. So I can now see everywhere that James Denard has logged in inside this network, just by running a quick scan against every one of the endpoints, looking at their event logs, log on events involving James Denard. Once again, Eric, I can do this with my SIEM. Okay, cool. If you have a SIEM, that's the place to go for this. If you don't, which as an IR consultant, there's never a SIEM, right? This is the next best way to answer some of those same questions. But folks, I'm gonna press through here. One last capability we can do from an IR perspective. If I identify boxes that I know were popped, of course, the next thing I want to do is stop the bleeding, right? Velociraptor will quarantine that system for you. I can even do it automatically. I could say, if you ever see ttcalc-back.exe execute, boom, quarantine the box, pop up this message to the user so they know what's just happened. I still have connectivity from Velociraptor. It can no longer talk to anything else. So ransomware, whatever, it's not going anywhere. That's kind of neat as well. But here, folks, I know we're out of time here. We'll post these slides for anybody that's curious. We're just talking about some triage acquisition stuff like my friend up here asked. Yes, Velociraptor can be your forensic triage acquisition tool to get all the forensic data that you need on an affected endpoint. But here, folks, I'm going to throw up our exit slide here. If anybody has any questions, we'll be around. Check out our booth over in the main lobby. Thank you so much for having us. Sorry for running late. Are you the next speaker?
What was that?
Are you the next speaker?
No.
Oh, okay.
No, definitely. I just had a question if you guys have.
Yeah, we're gonna try to get out of the way here. And just right over there if you want to. I'm happy to talk. Are you the next speaker? You're fine. Let me unplug here. Thank you. Appreciate it. Sorry, I didn't mean to cut short before I promised you about. But yeah, so we use Velociraptor as our triage tool. And what's awesome about it is it uses CAPE files. So familiar with CAPE?